on one tile, so on a reduced area. Then we can say that the first consolidated version is 1.1, which was released in May 2020, with some big evolutions like the move of the system database in a Docker container, also the possibility to do not pre-process the data, the Sentinel-2 data inside the system, but to directly read the L2A data pre-processed with Send2 Core. And at that time, we also organized webinars and question and answer sessions about this version. Then the two next versions, version 1.2 and version 1.3, are are made of corrections for some processors, adaptations, and small improvements, but no big evolution. And finally, we arrived to version 2.0, which was released in January this year. And you can see here what is new in this version 2.0. So we discussed a lot about that yesterday. So there's now a markers database. And this markers database will be explained in details in the next session. There's also a new algorithm which enables to detect tillage. It was in fact included in the L4C FR practices monitoring processor. And there will be also a dedicated session for the explanation of this new algorithm. Then, like I said, an effort was made to Dockerize the different components of the system, so the different processors and so on, to improve the modularity of the system. It's also possible now to use, so there's a new version of Maya for the preprocessing of Sentinel-2 data. And it's possible, the by default version of it is still the version 3. But if you want, you can switch to version 4, which has normally a better cloud detection and also custom corrections for the atmospheric corrections of the images. It was also mentioned yesterday, but since version 2.0, you can also use another DEM for the preprocessing of the S1 and S2 data. And it's especially useful for the European northern countries because it was also explained yesterday, the SRTM has this limit in latitude. Then what was changed here, it is said that in fact the communication between the different components or services of the system was moved to the HTTP communication. So it's another way to communicate between the different components. And finally, there were some problems fixed concerning concurrency jobs for the preprocessing of the data. So these are the major changes and the added features of version 2.0. And now I'm gonna give you an overview of this version. But before, I wanted to remind you how the system is operated, because it has also an influence on the design of the system. And it's always good to remind you how you should operate it. So first, the first thing that you have to do when the system is installed is to create a site. So you have to define an area of interest by uploading a shapefile with the extent of your site. You have to define a monitoring period, so the period that you want to monitor, and you have to choose if you want to use only Sentinel data or Sentinel data and Landsat 8. And once you have done that and you enable your site and your monitoring period, the system automatically will ingest the low-level products and begin the pre-processing. And as it was said also yesterday, Especially the preprocessing of Sentinel-1 data is heavy. It takes time. And so if you want to do it in a for the continuous monitoring, so in near real time, we advise you to begin this step, so to do this step early in the season, so that the system can pre-process already the data from before. And then when it's up to date, so it will just work automatically. And as soon as there is a new acquisition ready, it will import this new acquisition and do the pre-processing. So this is the first step. And at some point of the season, you receive the declarations from the farmers, and you are able to import this layer inside the system. You have to do that on the shapefile format. And when you do that, you can already, for example, use the markers database processor that we're going to see to extract the markers by parcel. And if you want to use the more advanced processors, so the crop type mapping, the grassland mowing detection, and the FA practices monitoring, you have also to upload additional tables to give some information to run these processors. So that's for the operation of the system. Now a bit a recap of the architecture of it and its main characteristics. So we saw this diagram already yesterday, and we're going to see the different parts one by one. But first, the characteristics. So it is using both Sentinel-1 and Sentinel-2. It's object-based, so all the analysis that are made by the advanced processors are object-based, so they are using the parcels, the limits of the parcels that you import. It is creating a markers database. You can operate it via a web interface, which is quite user-friendly. So your system can be installed on another machine, but you can operate it with a web interface from your own machine. It's open source, so it's using only open source functions and libraries. It can be used in an automatic mode, completely or partly, and you can decide also at some point to trigger new jobs. It's modular thanks to the Dockerization of the different parts of the system. It was explained yesterday that it was demonstrated at national scale in all 7 pilot countries. It can be used in near real time, or also you can use it to monitor a season in the past. And it can be installed on the cloud or locally. So these are the main characteristics. And now we're going to see the different parts of the system. And the first one is the one dedicated to the ingestion or the download of the low-level products and the pre-processing. As it was also mentioned yesterday, the pre-processing is mandatory for the Sentinel-1 data. And for the Sentinel-2 data, it's optional. You can either do the pre-processing in the system or read directly the Sent2Core L2A data. So how does it work, this part? So first, the system will query the list of low-level products that correspond to your site, to the extent of your site and the monitoring period on ESA Sci-Hub. In any configuration, it will do that. So it's why it's mandatory also when you install the system that you give information about the account on ESA Sci-Hub. And then it's going to use this list. If you define a local route in the data sources configuration where the low-level products are already available, and it's typically the case on a DIAS, which offers the possibility to have the access to these low-level products. it will just make a link to the low-level product. It can be a direct link or a symbolic link, or even you can choose to copy the data to your machine. So it will be fast to do that, to ingest the low-level product. And even there's also a mechanism, if the product is not available in this local route, it will then download it on ESA Sci-Hub. And if you don't have this local archive with the low-level products, it is the second case. Then the system will download these products from ESA Sci-Hub directly. And this is done automatically by the system. Then there's the pre-processing, and first the pre-processing of the Sentinel-2 data. So it corrects the effects of the atmosphere on the different bands of the image. You can see an example here with on the left the raw data, and then on the right the corrected image. And as I said before, so the L2A are so pre-processed data are already available on ESA Sci-Hub using Cent2Core processor. So you can either read directly this data, or you can do the pre-processing inside the system, and it is done with the Maya processor of solution. This is for Sentinel-2. Sentinel-1, so it is using Sentinel-1 SLC low-level product, and it is creating two pre-processed products. The first one is the backscattering. So here there's an explanation of what is the backscattering. So it's the measurement of the radar signal which is reflected from the ground towards the radar antenna in the same direction. This is the backscattering, and the second product is the coherence. And this is the, so it's using a pair of SAR backscattering data, and it's an estimation of the change between two successive data. So it gives you an indication on the stability of the vegetation on the ground. So this is for the pre-processing. Then the first advanced processor is the biophysical indicators processor. It's still at the pixel level. So to launch this processor, you don't need to import already the parcels. And there are 4 different biophysical indicators that are created: NDVI, LAI, FAPAR, and FCover. And for the 3 last one, it is done using the BVNet approach. And it gives you very useful information about the development of the vegetation on the crops. Then the next processor is a new one since version 2. It's the markers database processor. It will be explained in details after, but you can see that, in fact, the markers database processor process the basic markers, and there are other markers that are processed by either the L4C or either the L4A processors, but we're going to see that after. And then once it's processed, all these markers are available and accessible via a REST API provided by the system, or it is stored also, they are stored also in Arrow IPC files in the system. So if you want, you can also read these markers directly from these files. So we'll continue with the crop type mapping processor. So it was designed and some benchmarking work was done, first to select the best markers to distinguish between the different crop types. Then there was also an optimization made for the parcel selection for the calibration. There's a focus on the minor crops, which are the crops often that have the lower accuracy. So there's a smart process which enables to improve the performance in these minor crops. The processor provides the first and the second most probable crop types. And automatically, there's also a part of the parcels which are used to make an independent validation. This is a summary, of course, and it is explained in details in a technical document, which is available on the website. And this is an example of the product that you get with this processor. With the attribute table. So you can see here the crop type which is declared by the farmer, and then the two predictions which are associated with the confidence level. And on top of that, also in the system, it's possible to run a crop diversification code. What is doing this crop diversification code? First, it is doing an assessment at the parcel level. It is comparing, in fact, the declaration from the farmers with the two prediction, saying if the declaration seems to be conform or not conform, and also if the parcels is not classified, the reason why it's not classified is given. And then it was also explained yesterday by Sophie. We wanted to the rules in the crop diversification code are quite simple. They are the standard rules for all the countries, but we wanted to have the possibility to run that, because we can see that then that even if some parcels are not assessed by the system, for example, because they are too small, they will not have an impact on the crop diversification at the end, which is done at the farm level. So it's why it's useful. It was useful for us to develop this code. And on top of that, you have the results of the validation, which are also provided automatically with some figures. For example, this is the example of the F-score by crop type. So it's a measurement of the quality, the accuracy of the classification in each crop type, and some information about the classification, of course, the confusion matrix and things like that. So this is for the crop type. The second advanced processor, we can say, is the grassland mowing detection. So here the method, it's two time series analyses are done, one based on the Sentinel-2 NDVI and one based on Sentinel-1 coherence, and the processor will try to find decrease in NDVI and increase in coherence during the full period. It is also explained in details in a document on the website. And then these two results are combined together. And here we can see an example of a product at the end of the season. And so at the end of the season, you can get the number of mowing events that were detected, the date of each of these events, and also if you define some rules in the configuration table, a conformity at the end to see if the grassland parcel was conform or not following these rules. Also, as you can see here, some detection are done only by one of the two satellites, and some others by the two. And there is also each event is associated with a confidence level in this detection. And it is detected maximum 4 mowing events during the period. And now the last advanced processor is the FA practices monitoring processor. It is also a time series analysis which is done, this time based on 3 time series, the NDVI, the backscatter ratio, and then the coherence. And from this time series analysis, so weekly practice markers are generated. We're going to see these markers after. And then these practice markers are used to monitor 4 practices. So harvest detection, catch crop, nitrogen fixing crop, fallow land. In fact, a 5th one has been added since version 2.0, so the tillage detection. And it will be explained in details also in the next sessions. And then it's also possible to do a compliancy assessment if you define some rules in the configuration table that you upload inside the system. And these are the practice markers that are generated by this processor. The 5 first ones are used for the harvest detection, and the rest of them are used for the other practices that are monitored. So they are based on the 3 different time series that I mentioned before. And these are markers that are generated each week. In fact, they are true or false. And in the example here, you can see that, in fact, the markers are evaluated each week. And when all of them are true, it means that the harvest happened. And then here it's the case of a catch crop, which is monitored. So some of the markers from 6 to 10 have to be true during the whole period of the FR practice. So when it is the case, we can say that the parcel is compliant regarding the rules. And this is it for the overview of the system. And yeah, if you have any question, we are available to answer them.
Thank you, Philippe. Yes, there are a lot of questions in the chat. Some of them are answered, but maybe I can summarize the main ones. So there was a question about the spatial resolution of the Sentinel-1. So Sentinel-1 is 20 meters, Sentinel-2 is 10 meters, yes. 20 meters depending on the band, and all biophysical indicators are 10 meters. So the biophysical indicators are computed at the pixel level, and then in the database, the markers are extracted at the level of the parcel, being the mean, the standard deviation, and so on. There was also a question about how the overlapping parcels are dealt. And so here I invite the different persons from the consortium to answer, because this is not the same for all the products, basically. There is a question from Guido: how does a weekly NDVI marker work for the L4C when there is a cloudy period? And so I may answer, and then I don't know if someone from the consortium want to complement, please feel free. But so the practice processor is based on the analysis of both Sentinel-1 and Sentinel-2. And so we are using also the Sentinel-1. And so there are 2 ways of running the practice processor. The first way is really relying on Sentinel-1 and on Sentinel-2. And in this case, you can have some delay in the moment you get the information, because you ask the processors which rely on Sentinel-1 and on Sentinel-2. And so this is why sometimes you need to wait until there is a cloud-free Sentinel-2 image that confirms that there is vegetation or that there is a loss of vegetation. And there is another way of running the processor when you forget Sentinel-2 and you only rely on Sentinel-1. And so with this way of running the processor, you get a more near real-time results, but of course, the reliability is a bit lower because what we observe is really that the best accuracy is obtained when combining both sensors. And so really for the L4C processor, there is no smoothing, there is no gap filling. This is just really each acquisition is a point in the time series. I'm reading the last message. Is there any typology check on the input shapefile? Maybe Philippe, you can answer on the quality check from the shapefile that are done. And during that,
you mean of the parcel, or
yes.
I guess the parcel's shapefile? Yes, so there are some. So when you import the parcels inside the system, there are some checks that are done. So the geometry is checked. So if the parcels is closed or not. There was a question also on the overlapping parcels. There's a check also to see if a parcel overlapping other parcels with more than 10% of its area. It's also checked if there are duplicate parcels, so totally which have the same extent, really all the, and that's it. So a geometry check, overlapping and duplicate. And when you import the parcels inside the system, you have to define 3 information. So 3 attributes from your shapefile must correspond to an ID of the parcel, a unique ID of the parcel, the crop type definition, and then also a holding ID if you want to use the crop diversification. But otherwise, you can insert the shapefile that you want with the attributes that you want. And it can be in any projection also. Yeah.
Thank you, Philippe. So there are new questions coming from the interpolation or the gap filling. So the way if there is a gap filling or not really depends on the processor. And so for the practices monitoring, so there is no gap filling and there is no interpolation. For the classification, yes, there is a gap filling with an interpolation to have complete time series. So this is it depends. And so in the markers database, you will get both types of information, gap filled information and also acquisition coming from each, information coming from each acquisition. And there was another general questions that came several times in different forms. Is it possible to add other markers than what we have for the moment? So I mentioned it already yesterday. For the moment, the database only includes the markers that we used in the processor. And so this is the basic version of the database. And we should discuss, but I propose to do that after the presentation of the database. We should discuss if it's needed or if it's possible to add new markers, possibilities. What we don't know exactly how to do is I think each entity might have its own list of markers. And there are different, for instance, if you are computing a maximum, there are different ways of computing this maximum. There are many indices that can be derived, and so we will not be able to include everything. And so we need to find a way to select markers that are the most relevant. And this it's not yet clear to me how doing this selection, but maybe we can come back to this discussion after the presentation on the database.
Yeah, and we're gonna see the list of markers that are already extracted by the different processors. in the next session.
I think that I have gone more or less through all the topics in the discussion. Yes, there is a last one, and then we will move again for you, Philippe. So when the LPIS data is added or modified, does the system recalculate the markers for all fields or just the modified ones?
So it's just the modified ones. If I'm correct for the mark, at least for the advanced processor, it is the case. So for the crop time mapping and so on. So when you import a new version of your parcels, it will check if the geometry changed or not, or if there are new parcels, and then it will calculate these markers. And it is the case, in fact, only for the new parcels.
Actually, I think this will happen when the processor runs again. So we don't trigger a recomputation for only a couple of modified parcels.
Yeah, I mean, yeah, it's true. So when the processors are launched again, it will only do the extraction for the parcels that were modified, or for the new parcels, if I'm correct.
And the very last question, and maybe I will ask my colleague Lubos to unmute and to answer. So there is a question on the IFA practices. So there are different practices: catch crop, nitrogen fixing crops, and fallow. And Benjamin Kroll is asking if he can use one of these practices to detect mulching on fallow land.
Hello, everyone.
Hello, Lubos.
Hello, Sophie. The current implementation of the practice tools for practice check is based on a number of rules that form the subsidy scheme. So it's in some cases, especially in case of catch crop, is rather complex, and it gives the response about fulfilling the rules that are implemented within the tool. So the tool itself cannot be used to monitor or to check specific practice, but all the decisions for the practice are based on markers. So if any practice could have some if the practice that is to be monitored or to be checked will have links to individual markers, the simple rule can be constructed by the user to set up the monitoring based on the continuous way of generating the markers. So it will be up to the user to construct the rules, the decision rules that could be used to monitor or to check some specific activity or specific situation on the parcel.